Imagine you walk into a school fair. There are games everywhere: dice games, spinner games, prize boxes, mystery bags, and booths where you have to take a chance. Some games look easy to win, some look almost impossible, some are right in the middle. But if you say, "I might win," that is not very precise. What does might actually mean? Is it a tiny chance, a 50-50 chance, or a really strong chance? That is why we use probability. Probability is the mathematics of chance. It helps us move from guessing to measuring how likely something is to happen. Today, we are going to use a school fairground to help us understand the basics of probability. So before we go to the fairground booths, let us make sure we know the learning target for today. By the end of this lesson, you will be able to show how likely an event is using numbers between 0 and 1 on a probability scale. That means we are not just using words like maybe or probably. We are learning how to place chance on a scale. At one end of the scale is 0. 0 means there is no chance. At the other end is 1. 1 means the event is guaranteed. Everything else sits somewhere between 0 and 1. To make that easier to remember, we are going to think about probability as a chance meter. A meter helps us measure something. A thermometer measures temperature. A speedometer measures speed. A probability scale measures chance. So today, probability is our chance meter. It tells us whether something has no chance, a small chance, an even chance, a big chance, or is guaranteed to happen. This is helpful because chance is not always just yes or no. Sometimes it is possible, but very unlikely. Sometimes it is possible and very likely. The chance meter helps us describe that more carefully. Now, let us connect that idea to the actual numbers we use in probability. Probability always uses numbers from 0 to 1. If the probability is 1, the event is certain. For example, if a bag contains only red counters, then picking a red counter has probability 1. If the probability is 0, the event cannot happen. For example, rolling an 8 on a normal 6-sided die has probability 0 because there is no 8 on the die. The important idea is this: the bigger the probability number, the greater the chance. Numbers closer to 0 show a small chance. Numbers closer to 1 show a greater chance. The next slide puts those numbers and words together on one clear scale. Here is the chance meter written as a probability scale. On the far left, we have impossible, which matches 0. Then we move through unlikely, even chance, likely, and certain. Certain matches 1. Notice that probability can be written in more than one form. A probability might be a fraction, like 1/4. It might be a decimal, like 0.25. It might also be a percentage, like 25%. Those are 3 different ways of saying the same chance. The maths has not changed, only the form has changed. Also notice that every example sits between 0 and 1. That is a quick way to check whether a probability answer makes sense. Now that we understand the scale, we need a rule for calculating probability when the outcomes are fair. This formula is for situations where each possible result has the same chance of happening. That is why fair is such an important word. A fair coin means heads and tails have the same chance. A fair die means each face has the same chance. A fair spinner means each equal section has the same chance. The formula says probability of an event equals the number of favorable outcomes divided by all possible outcomes in total. Favorable outcomes means the outcomes we want. All possible outcomes means every outcome that could happen. For example, if we want an even number on a fair die, the favorable outcomes are 2, 4, and 6. That is 3 favorable outcomes out of 6 possible outcomes. Let us try that rule with a practice question. Here is a fair spinner with 10 equal sections. Before we answer anything, we should read the table carefully. There are 4 purple sections, 3 orange sections, 2 blue sections, and 1 silver section. If we add them, we get 10 sections altogether. Part A asks for the probability that the spinner lands on orange. So our favorable outcomes are the orange sections. There are 3 orange sections. Part B asks which color is least likely. That means we are looking for the color with the fewest sections. Now I'm going to model the answer by writing it out, not just showing the final result. So let's read the question again. Find the probability that the spinner lands on orange. Write your answer as a fraction and as a decimal. So here we are going to write probability of orange. And we can see that there are 3 sections that are orange, and it's out of 10 as we saw in the previous slide. Now we want to also give that answer as a decimal, and 3 over 10 just equals to 3.0. Part B, which color is the spinner least likely to land on? And then you have to explain how you know that. So in this case here, we would say silver. And the reason for that is because silver appears only once in the spinner. I will now show you the complete answer so we can check it clearly. This is just as a demonstration for you to see it written out by hand. So as you can see here, this is your complete solution. You can see for part A, you have the probability of orange equals to the number of orange sections divided by the total number of the sections, and we know that there are 3 orange sections and there are 10 equal sections in total. That becomes 3 over 10, which is 0.3. Which color is the spinner least likely to land on? The least likely color is the one on the fewest sections. In this case here, silver appears on 1 section only. This is fewer than purple, which appears in 4 sections. Orange in 3, and then purple in 2. Now it's your turn to try a similar question. Let's read this question together. A shop has a box of 12 mystery keyrings. Inside the box there are 5 football keyrings, 4 stars, 2 hearts, and 1 rainbow. Part A is asking for the probability of picking a star keyring and give your answer as a decimal to 3 significant figures. And part B is asking which keyring type is least likely to be picked and find its probability. Pause the video and have a go at the question. Once you have tried it, I will write out the method by hand so the reasoning is visible for you. Okay, you should have had a chance to complete these questions, so let's work through it together. So for part A, we are asked to find the probability of picking a star keyring and giving you answer as a fraction and then as a decimal to 3 significant figures. So if I want to find the probability of getting a star, that would be equal to 4 according to the table, all over 12. That's going to equal to 1 over 3. And if I was to put that as a decimal, that would be something like 0.333 recurring. But I'm asked to give my answer to 3 significant figures. So the answer would be equal to 0.333. So your answer would be in fraction 1 over 3, or as a decimal 0.333 to 3 significant figures. Part B, which keyring type is the least likely to be picked? Give the probability of picking this keyring. So in this case here, again, similarly to the previous question, we are looking for the least numbers of sections, or in this case here, least number of keyrings, and then we are asked to find the probability of it. So in this case here would be the rainbow, and so I need to find the probability of rainbow, of picking the rainbow in this case, will equal to 1 over 12. And therefore the answer for the first part of B would be rainbow, and then to find the probability would be 1 over 12. Now I will reveal the complete answer so that you can see it also written out much clearly. So you can see here there's lots of different steps trying to figure out each element of it. This is explaining it out much more clearly and step by step. However, if you did for part A, if you went from step 4 to 6, that's also great. And you can feel free to pause the video and have a go at reading this and seeing if you got the same answer. Now we have practiced this method, so we are ready for our question time. So now we are moving into the school fairground challenge. Each question is different. Each question will have a different booth at the fair. At each booth, we use the same big idea. Where does this event belong on the chance meter? Some questions use probability words. Some use a probability scale. Some ask for fractions, decimals, and percentages. The aim is not just to get the answer, but to make sense of probability. Let us begin with the chance words booth. At the first booth, we are using probability words before we use numbers. The words are impossible, unlikely, even chance, likely, and certain. These words sit along the chance meter from 0 to 1. Read each event carefully and choose the best probability word. Pause the video. Once you have chosen your words, we will check the answer and explain each one. The sun will rise is certain. It is not just likely for this question. We treat it as guaranteed. Rolling an 8 on a standard 6-sided die is impossible because the die only has numbers 1 to 6. A fair coin landing on tails is an even chance because heads and tails are equally likely. Choosing a blue counter from a bag with 1 blue counter and 9 red counters is unlikely. It can happen, but there are many more red counters than blue counters. A school day happening sometime next term is likely. It is not a single guaranteed date, but across a whole term, it is very likely that there will be a school day. Now we move from probability words to placing events on a number scale. On this booth, We are placing events on the probability scale from 0 to 1. There are 4 events labeled A, B, C, and D. Your job is to decide where each one belongs on the scale. Pause the video and read the questions carefully before attempting them. Okay, you should have had a go at that. So let's have a look at the complete answer. D goes at 0 because choosing a triangle from a box that contains only square shapes cannot happen. A goes at 1/4 or 0.25 because there are 13 hearts in 52 cards. That simplifies to 1/4. C goes at 3/10 or 0.3 because there are 3 yellow marbles out of 10 marbles altogether. This is slightly higher than 0.25. B goes at 1/2 or 0.5 because the even numbers on a fair 6-sided die are 2, 4, and 6. That is 3 out of 6, which is 1 out of 2. So the order from left to right is D, A, C, B. The further right the letter is, the more likely the event is. For the final booth, we will use fractions, decimals, and percentage together. At the spinner booth, the spinner has 10 equal sections, 4 red, 3 blue, 2 green, and 1 yellow. Because the sections are equal, each section has the same chance of being landed on. That means we can use our probability formula. Pause the video and attempt the question. Now let us check the complete table. For red, there are 4 red sections out of 10, so the fraction is 4/10, which simplifies to 2/5. The decimal is 0.4 and the percentage is 40%. For blue, there are 3 blue sections out of 10, so the fraction is 3/10. The decimal is 0.3 and the percentage is 30%. For not yellow, there are 9 sections that are not yellow, so the fraction is 9/10. The decimal is 0.9 and the percentage is 90%. All right, great work. This is the end of the lesson, and in today's lesson we use the chance meter, the probability scale, and the probability formula. The big idea is this: probability helps us measure chance clearly instead of just guessing.